So hello everyone, today we discuss contest 2. It was obviously harder than the first one, but it's actually not that hard, so we will discuss it. So last few problems are constructive problems. Constructive problems are usually tricky, so they require some insight from like this. You need to get some idea from somewhere, and nobody knows how it happens. So we'll discuss how you probably can approach problems like this, but if you didn't manage to solve last few problems, it's okay. You will learn. Two people solved all the problems, but they spent more time than the previous contest, so like more than 2 hours. That's good. So that's pretty much close to what expected for the difficulty of this contest. So I think difficulty is okay. So if you manage to solve at least like 4 or 5 problems, that's perfect. So good. Exactly, a lot of people participate. It's nice to see. Good. So let's discuss the tasks probably. Yes. So the first problem is usually very simple, and today is not the exception. So first problem is really simple. You just need to check the properties specified in the problem statement. So you have like this rectangle of digits basically, and you need to check that all the digits in the same row are the same, all the digits in consecutive rows are different. No, multiple ways to do it, just implementation problem. You just need to do it in any way you can. So again, I do it in more brute force ways as I can. So I just specifically check what's written in the problem statement. So I check for every row, I check that all the elements are the same, like this. I check every row, check every element, check that 2 consecutive elements are the same. Yes, here I check Boolean. Let's speed up a little. And here I check that consecutive rows are different. And here I say not equal instead of equal. So I will test it and find this mistake. But overall, that's the whole solution. So it's just simple first problem to start the contest, like we almost usually do. Sometimes you have first problem is tricky, but today is not. So today is just simple implementation problem. Nothing actually to discuss here, I think. So I think a lot of people. Okay. Yeah, there's even here. Some people managed to not to solve it. Okay, it's interesting. So what can go wrong? Let's find the mistakes here. Okay. NM last color, let's set colors. Okay. NM and okay, we read the color. Okay, so you read the row of colors. Okay, it's string. Okay, so you read the whole row. Set char color, set color, begin color. Okay, so you put them all in a set and check that size of the set is 1. Okay, so no, it's okay. It's possible way to check that all elements are the same, just to put them in a set and check that the size of the set is 1. It's correct. Okay, it's okay, it's not as fast as just checking that all elements equal to the first. Okay, easiest one to check that all elements equal to the first one. You pick one element and then just check that all other elements equal this one element. But okay, who am I to judge? So it's correct approach. If last color equal color, then you have false. Okay, so if you have 2 identical lines, then it's false. Okay. Colors and set color. Why you checked colors? You don't need to check that all lines are the same. You need to check that consecutive lines are the same. So that, okay, so in this example, all 3 lines are the same, but you need to check colors of adjacent rows different. Yeah. Okay. So it happens. You misread the problem statement. Again, it happens all the time. Happens to me every second contest. You read the problem statement, miss one small detail, and solve different problem. Okay, if it happens to you, you get wrong answer, you have no idea why. Read problem statement once again. Probably you just solved different problem. Again, I encourage you to find all the mistakes in your code. So it's a very important skill, not only to solve problem, but also to find mistakes in your solution. will help you a lot, not only in the competitions. Let's talk about second problem. Second problem is also easy. Okay, requires some careful implementation, but again, because size of the input is large, so size of the input is like 100,000 elements, so you need to at least do it carefully, yeah. But idea is very simple. So we need to find two minimums close to each other. So I will do it in two steps. I first will find minimum, then find all the minimums and check two consecutive minimums if the distance between is yeah, like here. So here this first loop finds the minimum. In this second loops just finds two consecutive elements and check which consecutive elements are closest to each other. Yeah. So here there's the whole solution. You can do it in a single loop actually. Yeah, so you can make a single loop. So every time you find the new minimum, you just clear the current result. So you just do the same, yeah. But if your minimum is better, so if you have the element equal to your minimum, you do this thing. You just compare to the previous minimum and edit the result. And if you find the new minimum, if you have the element less than your current minimum, you just clear this result. Okay, because now I find the first element equal to my minimum, and just continue. So you can do it in one one loop, but you don't require to. Okay. So in a problem like this, I usually prefer to make code which is more clear. Okay, it's maybe not the best code in the world, but at least so I minimize number of mistakes here. Yeah. So if I can do it in two steps, first find minimum, then find this. Yeah, I will do it in two steps if I can. Sometimes I want to flex and I do it in a single row just because I can. But here I want just be as safe as possible here. So just very safe approach. Yes, just do it in a way that you are sure you can do without mistakes. Okay, third problem is actually fun. So third problem is fun. I'm actually curious how did you solve it. We will look at your solutions in a moment. So third problem. So we have two people. They eat the chocolate from two sides, and they meet somewhere in the middle. Yeah. And the question is, who will eat how many chocolates? Yeah. So one is eating chocolates from left to right, another is eating chocolates from right to left. We know how much time we spend for each chocolate, and we want to find out who will eat how many chocolates. Many different approaches actually solve this problem. You can do it, for example, you can do it using binary search. My first idea was to do it using binary search. No, not here. This is not binary. This is 2 pointers already. But I considered this possibility. Yeah. So you can do it binary search. So if you do binary search over time you spend, then you see. Okay, let me show you. So you can do it using binary search, and it's actually in many problems it's just the way of thinking. So if I have problem do something, I want to first apply binary search and see if the resulting problem is easier. So here, for example, I can binary search over time and find how much time I spend until they meet. Yeah. So if you spend some t time, then first person will eat Alice. So Alice will eat somewhere from here, and you can just greedily see how many chocolates Alice will eat. And Bob will eat some chocolates from right. Yeah. So this is the maximal amount of chocolates with some not greater than t, some not greater than t. And then you just find the maximal number t such that they don't meet. And then just see what will happen after this time. And they will meet in the middle, and you will see like one of them will eat the last chocolate. Yeah. One possibility. I decided then, but so that it actually can be solved without binary search, and it's not much harder. Actually, maybe even easier to do it without binary search. So instead of binary search, I do something like a simulation. So I just make 2 pointers and make a simulation. So I have 2 pointers. So Alice is eating this chocolate, Bob is eating this chocolate. Yeah. So my current state is like this. Alice is eating chocolate L, Bob is eating chocolate R. and I see what will happen next. Yeah. So one of them will finish the chocolate and move to the next chocolate. Either Alice will move to the chocolate to the right, or Bob will finish and move the chocolate to the left. Yeah. Now you think about corner cases. Okay, if this happens before I do this, this happens before I do this, what will happen if both events happen in the same time? So if they finish eating chocolates at the same time, what will happen? And usually you don't care. Yeah, so Alice will move here, Bob will move here. The only place when you care is then you have last chocolate. When you have last chocolate, you have this L, you have this R. Okay, so if they finish these two chocolates at the same time, then, like it's stated in problem statement, so it specifically says in problem statement here, you problem, let's see. So if they finish the same time, then the last chocolate will be eaten by Alice. Yeah. Okay. Yeah. So if it's kind of like it, I move Alice, and I decided to do it like this. So I will just do it like this. So if both events happen at the same time, then I will move Alice. Yeah. So I will move Alice if she like imagine if Alice started eating like half a second before. Yeah. So if they finish at the same time, then Alice just have advantage. Yeah, that's it. And then I thought, what about corner case? Corner case is when I have only one chocolate. And in this case, it will be eaten by Alice. Yeah. But since I started from putting both elements at the same position, I will just, so if I have n equals 1, then initially, like, they both eating the same chocolate. So instead of doing this, I will move both to position n here. So I will add another chocolate with times 0. Again, it's basically just a trick to handle this single case. So the single case is when Bob doesn't eat anything. Yeah. So I just put the Bob outside of this array. Here I'm just thinking. Let's keep me thinking. I think about this specific case. Yeah. Think a lot. Yeah, and here you see, here I put R in position n. So I put this R, one element outside of the array. So I add one, see, one additional element. It will be 0. Yeah. And I initially put Bob in this 0 chocolate. So Bob will finish this chocolate immediately and move to the chocolate on n-1. Yeah. The only problem it solves is when I have n equals to 1. You can solve this problem by making additional if. You make this if, you make if n equals 1, just print 1, 0. It's another way to solve this problem. Okay. Again, think about corner cases. So when you solve a problem like this, especially, you think, what may be corner case, how to handle it. If it's handled just by your algorithm, it's okay. If it requires some special handling, okay, do some special handling. Yeah. That's it. Okay, let me show the program. So what I'm doing. So I'm just maintaining 2 pointers. So Alice is eating this chocolate, Bob is eating this chocolate. Yeah, and I move from in both directions until I meet at the same point. So until they eating consecutive chocolate. So I finish like in binary search. So I will finish, then they eat 2 consecutive chocolates. So if this chocolate is eaten by Alice and this chocolate is eaten by Bob, I just stop. And I basically mark all chocolates who eats this chocolate. Yeah. Now here I check what happens first. Who will eat the chocolate? Yeah. And if Alice will eat chocolate before Bob, yeah, I just decrease the size of the Bob chocolate by this amount. Yeah. See, and move Alice 1 position to the right. And if it's not, I move 1, it's n-r, because it worked. Okay, you can output L plus 1. So the final position of Alice is L. So Alice will eat all chocolates from 0 to L inclusive. Yeah. So it's L plus 1 chocolates. No, L plus 1 just equals to R. Maybe L plus 1 is more clear, okay? But R equals L plus 1, so it's... And Bob's everything, all the rest. All the rest just N minus R. Okay, here I didn't think that much. I just put something that should work, okay? So not the clearest implementation, this last part, but again, this part at least, so for this final print, so okay, it's okay actually, yeah. But it doesn't make sense to put R in position when you have number of elements in the left. Why is it R? Okay. No, put L plus 1 here if you like. Okay, so that's problem C. Let's read your solutions. I'm actually very curious about your solutions for problem C. Do you have something more beautiful? Okay, this is very close to mine. Okay, here instead, so we don't change the elements, but instead we we calculate how much time do we spend eating chocolates. Okay, and if Alice finishes first again, we have less or equal because Alice has priority. So we eat this chocolate and move to the next. Okay, I and Ans actually the same. So they equal 0, and then you increase them simultaneously. Okay, so you have two variables doing the same thing. Okay, but it's okay. Okay, no, it's okay. It's pretty much the same implementation. Does anyone implement binary search? I'm curious. Ooh. Okay, that's really strange implementation. From I to N and element less or equal than last element divided by 2. We have prefix sums. Okay, we calculate prefix sums. Okay, so we calculate prefix sum, which is less or equal than total sum divided by 2. Okay, now it makes more sense. Okay, no, it's clever solution, but I think it's overcomplication. So you actually don't need prefix sums here. I can only tell me your handle. LGM LG. Okay. Let me read your binary. I love to read binary searches. Oh yeah, nice. Perfect binary search. So we have -1 into n plus 1 just because you can. So I would say n plus 1 is too much, but because okay, better safe than sorry. Okay. So middle put here if f of mid. So what is f? Less than so. You do binary search by the number. Okay, so now it doesn't make much sense. Okay, so basically you're calculating you do binary search over array of size n, and this work in constant time. So okay, so you can replace the linear search as well. So okay, because this function works in constant time, so you basically this binary search works in log n time, yeah. But your initial construction works in linear time. So you spend linear time here and then log n time here. Okay, it's not stupid. It's working. No, so no. Any solution which passes all the tests is not stupid. It's working solution. So you wrote it. You solved the problem. That's what matters. Okay. You don't require to write the clearest possible solution every time. You require to write solution which passes the test. It passes the test. Yes. That's the important part. Problem D. Okay, we have a few constructive problems in today's contest. I would say they're very math-heavy contest today. So first math problem is to find the Pythagorean triple which includes the given number. So we're given one number and we need to find two another numbers such that it's possible to build a right angle triangle from these three numbers. Okay. If you solved a lot of mathematical problems, that might help for problems like this. So if you participate in math competitions, if you just like solving math puzzles, definitely help. And in general, it will help you to in programming competitions if you are good in math competitions. So it will just help. Okay. So if you don't like solving math problems, I highly encourage you to just go and find some site with math problems and just solve them from time to time, just to keep your brain trained on solving math problems. Okay. So what we do here, for example, we have a number and we need to find two numbers to have Pythagorean triple. Okay. If it's not clear for you what to do, it's okay. So what can you do? You can look at the examples, for example. So you can look for some hints, yeah. And just first thing I usually do when I have some constructive problem like this, so you just need to find some object somehow. I will just start by just looking at some examples like here. So I have some examples: 3, 4, 5. Okay, 3, 4, 5. I know it's Pythagorean triple. Yeah. Then 6, 8, 10. Okay, it's the same Pythagorean triple multiplied by 2. Makes sense. Yeah. 1 is minus 1. Okay, it's impossible to make Pythagorean triple with 1. Okay, why not? And now I have a few examples here. Okay, now actually if you look close at these examples, you may find already what's happening. What you may notice that these numbers are different by 1, for example, and these numbers are different by 1. Here actually judges spoiled you the idea of the solution. Sometimes it happens. Sometimes judges make specific tests to hide the idea of the solution. But here they decided just to give these examples as a hint. I'm not sure why, but sometimes judges do this. Okay, so again, this may give you at least some idea about how the solution looks like. Now, what other hints you may have in this problem? For example, you may have look at the constraints. So here number n is up to 10 power 9. Okay, but numbers you need to output can be up to 10 power 18. Yeah. So this kind of suggests that the numbers you are looking for can be up to n square, right? Okay, so again, this will give you some hints in which direction you need to look. Yeah. Okay, here I believe, so I will write. Okay, yeah. Now what I'm doing, I just write in the formulas and look at them. So here I have, I think about my number. So you have two options. Your number is either a hypotenuse or it's one of the catetus of this triangle. So I'm thinking if it's one of the smaller sides. So if I do it like this, then n square must be equal to k square minus m square. Yeah. Why I'm writing like this? Because I know that like difference of two squares can be represented like this. Yeah. So I know that I can do something with the difference of the squares, so I do this. Yeah. So again, this is the first thing I'm looking at. So because I think it's promising. Then I think, okay, I need to find numbers k and m with these properties. I think, okay, may I make this difference equal to 1? Again, you have two examples here. Yeah. In both examples, here and here, difference is 1. Yeah. So I need to make two numbers with difference 1 and sum equals to n square. No, you can do it if this n square is odd. Yes, if n square is odd. Okay, let me write here. If let's say n equals 5, yes, then n square equals 25. You can split it into two numbers with difference 1. Yes, so 25 equals like 12 plus 13. So that's your answer. Now, if n is odd, if n is even, so if n is even, what to do? And again, you have hint right here in the problem statement. So here is the hint, yeah. So what do you need? You just need to divide it by 2 and do the same thing, yeah. So if n is even, I will divide it by 2, find this triple, and then multiply it back by 2. So I will have 6, 8, 10. What if I divide by 2 and still have even number? I can divide over and over again. So if I have number, let's say 12, yes, I divide it by 2, get 6, then again divided by 2, get 3, then make this triple, and then multiply it by 4 to get the initial. Yeah? So you have 12, 16, and 20. Yeah, sounds okay. Sounds okay. Now I think when I have so sometimes some solution is impossible. Yeah, you have examples. You have so for one there is no solution. I think okay. For one it's impossible. What about other numbers? So here when I divide by 2, at some point when I have number 8, I get number 1, and here I put myself into impossible situation. Yeah. So I divide by 2, then I have number 1, but for number 1, it is impossible. So I think maybe for powers of 2, it's impossible. Okay, but then I stop. I think, okay, but for 4, it's possible. I know it's right in the problem statement. Yeah, for number 4, I have triple 4, 3, and 5. So I think, okay, if I have any power of 2 greater than 4, I'm fine. Just I do all the same things. I just stop it at 4. I just need to do something in here. For -1, it's impossible. So print -1. So the only number I don't know what to do with is 2. Okay. And then I spent few minutes thinking if it's possible to have 2. And I convinced myself it's also impossible. But because you need, so if it's 2, you need 2 numbers with square different by 4, and difference of 2 squares cannot be 4. Okay. At least I convinced myself it's impossible. Okay, here I'm just thinking about 2. Okay, here you see how I just looking at number 2, I convinced myself it's impossible. Sometimes it's okay. You don't need to get formal proof. You may have formal proof, but you don't need to. If you believe that you have single strange number, so if I get wrong answer, I will look back to the whiteboard and think, okay, maybe it's possible for number 2. But I didn't get the wrong answer, so means okay. So again, programming competition is about time management. Yes, so if you have some hypothesis and it looks very promising, sometimes you don't need to prove it. Yeah, you just believe in it, implement it, submit it. If you get wrong answer, then you move back and think. Okay. Okay, let's see me implementing it. So okay, so the implementation is very easy. So here, I'm dividing by 2 until I get number at least 4. So if I get 4, I will stop. Okay. So in the end, I will have number like, okay, even I either have odd number or I have number 4. Yeah. So if I have 4, then I make this triple. If I have some odd number, then I make another triple. And here I made mistakes, not n, so it should be not d but n. And here I made another mistake. It's okay, we'll fix them. Again, then I multiply it back by the d. So d is the number I divide to. The problem is correct. Errors implementation. Yes, that actually happens a lot. So your idea is correct, but you made mistake in implementation. Yeah. Also learn how to do how to deal with it. Yeah. Okay. In hard problems, the most important technique to handle this situation is stress testing. So you create easy solution, you create just your normal solution, and like easy solutions, just some stupid solution, some non-optimized solution, and just stress test and find the test that doesn't work. Very powerful technique. We will talk about it in some lecture future, I believe. I need to record video about this. Oh, it's another solution for even n. We have n squared divided by 4 minus 1 and 4. Let me think. Let me think. What? N squared divided by 4 minus 1 and n squared divided by 4 plus 1. Makes sense. Okay, so the sum of squares of these numbers will be, again, it will be sum multiplied by difference. Difference is 2, and sum is like n squared divided by 2. Yeah, so it's n squared. Nice. Okay, another approach. Love it. I love it. Okay, so there are multiple ways to do it. Good. Let's look at your solutions, actually. Okay, I'm not sure. I think it's the same formulas, but okay, these are formulas. Okay, you just told me. This looks like the same. So for even numbers we do this, for odd numbers we do this. Looks fine. I think we have just integer overflows. Yeah, we have LL, but this number is int. So when you multiply, you have integer overflow. Yes. Yes, probably yes. Yes, you have integer overflows here. Oh, okay, happens. Okay. So in my solutions, just last few, I'm trying it only this season. Last season I also struggled with these situations. This season I'm doing it like this. So I'm just trying to just get rid of all 32-bit numbers in general. Yep. So if you struggle with integer overflows, so maybe you also need to try something like this. Oh, that's a lot of code. What? So you take number n and split it into divisors, right? I have no idea what's happening here. So you try to find some divisor. Okay, you split an x and y, so into two parts. And you want to do it in such a way that the sum of this is even. No, okay, if sum is even, difference is also even. And then do it like this. Okay, that's something really smart. I have no idea what's but if it works, it's okay. If it works, it's okay. So you just instead of finding like easy mathematical solution, you do it with programming. No, and also some math. So you just power up your math skills with your programming skills. I actually respect this. No, that's good. So again, the only property of the solution which matters is if it passes all the tests. Okay, let's move forward. Here I accidentally moved to problem F instead of problem E because I misclicked. So if you look here, so I just so I go problem D, and then I decide to move to the next problem, and I misclicked and go to problem because problem E was already opened before for some reason, I don't know. So it was purple. So I moved to problem F instead. I actually was very surprised it's that difficult. After the previous problem S is much more difficult. And that's because I missed problem E, actually. So we'll solve problem F first, then move to problem E, because that's what I did in this video. Problem F is really fun. I actually enjoyed solving it. So we have what we have in problem F. We have elections, and we have some people already voted, and some people just didn't vote. So some A people already voted, and other M minus A people, they will vote later. And we need to check what may be the result of this election. So for every candidate, we need to get one of these three results. Okay, I believe I didn't draw that much pictures here, so let me explain what's happening here. So I will write the code, and then here on the right I will explain what's happening. So what's my plan? So first I will count all the votes and sort people by this voting. So I take all people, sort them in decreasing order by number of votes, and if number of votes is the same, sort them by the time of the last vote. This is what's written in the problem statement. So I sort them in the way it's written in the problem statement. Now the idea is like this. So if for any candidate from this part, I need to check. So he's already in the winning part. So this first K candidate. Yeah, K candidate. So they have positions from 0 to K minus 1. Yeah. So if I'm already here, then I just need to check if it is possible to get out of this position. So for me to get out of this camp, I need to take these next people here, and I need them all to overcome me. Yeah, and I just count how many votes I need for all these people to overcome me. Yeah. If I am standing here, it's easy actually. I need to check if it is possible for this candidate to go into first K positions. To do this, this person just need enough votes to overcome this K minus 1 person. Okay. So I need to, so I have several cases. So several people should be processed differently. Also, there is a special case when some person receives 0 votes. Because in problem statement it says, okay, let me show you. In problem statement it says specifically here, somewhere here. Yeah, so there's no vacancy with 0 votes. So if some person receives 0 votes, it's some special case in some sense. Yeah, so I try to just treat it separately. So I just, okay, I will finish it. Give me some time. Finish all this. Okay, I will rewrite it several times. So let's have some stable version. Yeah. Oh no, it's too far. Too far. No, okay, let's move here. Well, let's read it actually here. So it's hard to read in this video. Let me just take my code and we will discuss it. Let's get elections here. Copy. Just open it in C-line and read. So let's just read it together. So what's happening here? Let's see. So here I'm just implementing what's written in the problem statement. Yeah. So I count for every person. Okay. So not the best way to implement, but again, that's okay. So I count number of votes and the time of the last vote, and then I sort. I sort in decreasing order. Okay. I decrease the order by number of votes. But by the last vote, I need to do it in an increasing order. So I do it in decreasing order by number of votes and in increasing order by the last vote. So I just do last vote in minus I. So I just do negative the last time. So this sorting will do what I need to do. Okay. Alternatively, you can do this. You can subtract here and then do normal search here. Normal search here. Okay. But I kind of want to keep this. I will use these values later. So number of votes is important value. I will just keep it as it is. So I don't want to make negative. Okay. Sort. Here I pre-calculate prefix sums because I will need them later. I will talk about it. Yeah. Now I just write the code as I'm thinking. So I need this code to be clear, so I don't make any mistakes. Yeah. So it's clear to myself. Yeah. So I just think about some cases I need to handle and handle them one by one. I think that the case when I have 0 votes is special. So I just make special if case for this, just for 0 votes. So if I have 0 votes, what I need to do? To be in the first k positions, I need to overcome the person in the k position. So I take the person in the k position. He has x votes. To overcome this person, I need at greater than x votes. Yeah, strictly greater. Yeah. So I check if I have enough votes to overcome this person, then result is 2. If not, the result is 3. Yeah. Now I handle this stupid case when I have 0 votes. I don't care about it anymore. Yeah. So that's it. Okay. So again, if you just don't like some special case in your program, sometimes you just make a special if that handle only this case, and then you don't have any problems with this case anymore. And another special case which I don't like is when k equals to n. If k equals to n, it means all the people will go to the will be elected anything. If they have more than 0 votes, all the people will be elected. So I just say equal to 1. So if I have more than 0 votes and k equals to n, I will always be elected. Okay, so I handle all the tricky cases which I don't want to think about. Now I think about general case. Yeah, in general case we have 2 options. If I am outside of this scope, so if I'm not elected now, then I have choice between 2 and 3. So I either can be elected or I cannot be elected. Yeah. So I check. So to be elected, I need this number of votes. I check if I have enough, then I can be elected. If not, I cannot be elected. Now, if I am already in this in the group of the first, I need to check if it's possible to me fall out of this group. Yeah. And for me to fall out of the group again, let me show you. I need these people here all overcome me. Yeah. So if this person is me, yeah, this person is I need all these people overcome me. Yeah. To overcome me, they all need to have some extra votes. Yeah. These extra votes. And I need to count how many votes do they need in total. Yeah. Again, like this picture suggests, I take this rectangle, you see, and then subtract this section in the bottom. Yeah. So this section in the bottom is just suffix sum on the segment. Yeah. And this thing is just number of votes plus 1 multiplied by number of elements. So they all need to have votes greater than me. Yeah. So that's what I'm doing here. So here I calculate how many votes they need in total if all of them want to overcome me. Yeah. So they want to have at least me plus 1 votes, and that's number of them. Yeah. And that this suffix sum is just sum of the current votes. So that's how many votes they have now. That's how many votes they need to have to overcome me. Yeah. This is just suffix sum I calculated here. That's it. I check if I have enough votes to cover this difference, then it's possible that I vote for these people and they all overcome me. I will fall out of this first k candidates. Yeah. So answer is 2. If it's not enough, the answer is 1. I will always be in the first k. Again, code is tricky, but every part is kind of it at the correct place. Yeah, so just think about cases you need to handle them carefully. And again, sometimes you have more cases, sometimes you have less cases. Usually it's better to write solution when you have less cases possible. But if you have like 4 or 5 cases, it's okay. Yeah, you just handle them carefully, think about them, and just try not to make any mistakes. Okay, that's easy to say, not to make any mistakes. Yeah, nobody knows how to not to make any mistakes. Let's look at your solutions. Okay, you didn't solve D and F, but solve F. That's surprising. No, it's good for you. So again, that's good thinking. So if you didn't manage to solve some problem, just don't give up. Try to solve another problem. Sometimes maybe harder problem is easier for you. It happens. Oh, it's shorter than mine. Let's see. So I read all the calculate and calculate number of votes and the last vote. Multi-set. Okay. Go for people in flag. Add massa plus plus. So you just simulate. Because number is small. Aha. Okay, so do you have small constraints? I didn't look at constraints. It's just 100. Okay, you don't need prefix sums like I did. I don't know, for some reason, sometimes I overthink, yes. Okay, you don't need, okay. You don't need prefix sums, you don't need anything, you can just simulate. Good thinking. So you just simulate this, simulate this thing, try to do what you need to do. So you try to make this person in the first k element or try it out of first k element and check if it's possible or not. Nice. Good thinking. Why don't you solve these problems? Let's look at your mistakes. Since we are looking at your solutions, run count 66. Oh, surprisingly. Why do you need non-integer numbers here? Is it the only problem? Okay, let me show you how to do it. So I believe the problem is you are using floating point arithmetics. That's something you don't want to do in integer problem normally. Yeah, let me pop. So here, okay, so if number is odd, so here I wanna have n divided by 2, yes, and y will be, so x is divided rounded down and y is divided rounded up. So you do it like this, you say x equals x, not x, okay, x divided by 2 and y equals x plus 1 instead of this. Will it solve our problems? So let's see. Do you have any? Here. Why? Or do you really need this check? Oh no. You have more floating point arithmetics. Okay, it will probably not work, but we will check anyways. Just try to avoid floating point numbers as much as possible. If your input is integer, your output is integer, all the calculations integer, try to avoid floating point, especially in Python. So the big difference between integer numbers and floating point numbers. Integer numbers are always precisely correct. You don't have integer overflows in Python. But for floating point numbers, you have some fixed number of digits. Yeah. So if you need more than this number of digits, then last digits are just truncated. So you don't. And in this problem, you have huge numbers like 10 power 18, and I believe it's out of the number of digits in Python floating point numbers. Okay, so this was problem F. Okay, nice problem. It requires both mathematical thinking and programming skills. So really interesting problem. Really enjoyed actually solving it. And here I move back to problem EE. So problem E, again, I'm choosing some random number. So first number, again, problems like this, I make a random cyclic shift, yeah, and I look at the first position. I look at the first position, then I decide at which other position to look. So I look at the first position, get some character x. Then from this character x, I move like d positions to the right and look at this character. And I need to guess what is the cyclic shift. Yeah. To make a cyclic shift, okay, so I need to have unique. Wait, so I know this number x, or this character x, this character y. Yeah. So to guess the cyclic shift uniquely, I must have only single pair xy which produces this result. Yeah. So only one cyclic shift have characters x and y on distance d. Yeah, so that's what I need to do. So I need to check for distance d if some characters x and y occurs only once in the string. So that's what I'm doing. Here I spend a lot of time just thinking: do I do maps or arrays? Because sometimes I do both. So depending on the problem, sometimes I make like vector of size 26, like here, and sometimes I do map from char to int. It's okay. No, vector will be slightly faster. Here is not a problem. So here I have linear solution. So it's not a big problem if you have extra time spending on these maps. So it's not that big difference. It's more like aesthetical purposes and like clearness of the code. So here I rewrote it a couple of times. I ended up using vectors just, okay. Here It's just fun to watch me swapping it back and forth. Okay, I will. Okay, here I will swap it once again. Here I decided to have full vectors, only vectors, no maps. Vector. Yeah. So so let's look at the problem. So what I'm doing here, I look at all characters here. Take the character x, just subtract a to have number of characters from 0 to 26. Count how many characters I have. Then I look at all possible distances. Look what character I have after this distance to the right. And count how many situations I have. So for every situation, like pair of characters plus distance, I calculate how many times I have the situations. Okay, here I decided, that's probably from my Java experience. In C++, it's not that important. It will still be fast. In Java, it's just very important to have small sizes to be first. You have multi-dimensional array. Here is not important, but I just used to do it like this, so I keep it to do it like this. So my vector dimensions will be x by y by d. Yeah, so x and y are two characters, d is distance. And here I check all the characters. If I have only single character here, I immediately know the result, no matter what I will pick. And here I find the best value of d. So I check all values of d, see how many pairs do I have. If I have only one, then I increase number, and then I just count how many good characters I have. Yeah. So for every position d, I check how many good characters I have. So if I see this character, I uniquely find what triple do I have. Here I miscalculated the formula. Okay, here I thought I need to find, this is probability that I will pick character x. I need to multiply it by probability that I will find character y. So I did it wrong. Okay. I did it like this. So I thought I need to. Okay, it looks suspicious when I look at this formula now. It already looked suspicious. But I spent some time figuring out what's going on. Added some debug output. Look at it. added some another debug output, more look at it. Okay, so everything up to this point looks fine. But the result is incorrect. So all the calculations looked correct, but the result is incorrect. So again, I looked at this formula in the end and find the mistake. So I need to divide here not by n, but number of CNTT, because okay, so okay, this probability that I will pick this number, knowing that I already picked number x. Yeah, so I need to divide not by n, but CNTx. And then they will eliminate each other, so I just need to simplify this formula. Yeah, I move this. Yes, you do like this. So that's it. That's the final formula. Turns out to be very simple formula. I didn't believe it first when I wrote it, but again, let's read the solution one more time, actually. So because this problem is tricky. Okay, today I learned you can initialize vector like this. So this is three-dimensional vector, vector of vector of vector. You actually don't need to have all this stuff. Okay, that's why I submitted twice. So before I always do it like this, but today I learned that in modern C++ you don't need to do it like this. Modern C++ can actually deduce what type of vector you have, so you don't need to have template when you have it here. So C++ now can guess. Okay, so this is my three-dimensional vector. Again, I look at all triples, so I pick one character, find the distance, find another character, count this triple. Okay, now I look at every first character. If it's unique, I believe you don't need this, actually. Yeah, I believe you can get rid of this. So if it's unique, you will just here you have best equal to. It doesn't matter. So if it is unique, you just add to result. If it's not, you find the best possible distance. You check all possible distances, check how many good characters you have, and then just add this to result. So this best distance will give you this probability of success. That's it. That's the whole solution. Baba Budidia. Answer 0.8, answer is 1. Okay. Deck. That's interesting. Ah, you're doing cyclic shifts. Okay. Okay. That's another way to doing it. You have an order map. Why not? Ah, an order map. What? Okay, I will read. So here I just make all cyclic shifts and put them to this array. Okay, so to this array, I put all possible cyclic shifts of my string. Good start. Now here, okay. Check 1 to n. Comb of j. J is distance, yes. So I make cyclic shift. Then position 1 will in this actually will be just it's like a position you're looking for. Okay, string 1 i0. Okay, just string of 2 characters. Okay. In position 0 and a plus plus. Okay, so for every pair of these 2 characters, you make plus plus. Okay. Okay. No, this part looks correct. Okay. So something here, max good for one. I think you decide what distance you pick in the beginning, but you can decide after you pick the first element. So you pick the first element, then decide what will be the second element. And here you pick the optimal value for all distances. So you decide you will pick this element and the element in between. So you decide which element you pick before you open the first element. And that gives you less probability. Yeah. Yeah, I believe that's what's happening in this case. Interesting how they build examples like this. So for any distance, you have some probability of having not unique characters. But for any character, there is a distance that gives you some unique choice. No, it's actually a very complicated mistake. So again, it's hard to find mistakes like this, and you're not able to make stress test here. You can, but okay, I don't know how to make stress test here. Yeah, you can. Yeah, it's very hard to find mistakes like this. Oh, problem G. You asked me in Discord about problem G. Give any hints about problem? So let's talk about hints. So what hints can we have in problem G? Again, problem G is problem when you need some constructive solution. So you need to construct some object with given properties. Again, the most important hint given you by the inputs that so it says it's guaranteed subject. So they give you, so it just tells you. In some problems they don't guarantee you that answer exists. They just don't give you examples of impossible. Yeah, here they just specifically in the text guarantee you that the solution exists. Okay, and that's actually a big hint that solution always exists, because you start thinking why it always exists. Okay, then after you start thinking why it always exists, you try to manually solve some corner cases. That's many ways to approach problems like this. What I usually do, I first just to start playing with this model and solve some corner cases. So what corner cases do I first look at the examples. If you look me here, what I'm doing here, I first draw all the examples just to see what's going on. Okay. So see, I get first example. I see that I have this. I have two nodes with degree 4, two nodes with degree 3, and one node with degree 2. Why? I don't know. And here I have 1, 2, 3. I have something like this. Then I start to write node, and I find I want to start by again thinking about the corner cases. So you find the most difficult case in some sense, yeah, and think how. So because you know the solution always exists, you try to find the most difficult situation. Because when you have difficult situation, you kind of have less space to wiggle. Yes, no. So you have so you see how the solution is built. Because usually when you have some corner cases, you have just less space to do it in different way. You know, you have only one way to do it, and you just build it and see how you do it. Okay. It's hard to explain. Yes, hard to explain how do you solve the problems. Nobody solves how you solve problems. So here what I'm doing, okay, I will draw it. Okay, here what I'm trying to do, I try to solve case when I have all the numbers from 1 to n. It looks like different case, a difficult case, yes, because I have many nodes with different degrees. Yeah, so I see what's going on if I do it like this. I see, okay, I need to have a node of degree 4. So let's have a node of degree 4. I think, okay, good start. Yeah. So I think, okay, now I need to have a node of degree 1. I already have one. So now all the nodes have degree 1. And I need to have node of degree 1. Yeah. So now I already have node of degree 4 and node of degree 1. I only need to have node of degree 2 and 3. So what I'm doing here, I'm trying to reduce my problem to the same problem of smaller size. It's some kind of mathematical induction happening here, right? So you're doing something to have the same problem but smaller. See? Yeah. So here I think, so in this region, I need to have graph of these 3 nodes, and the degrees should be one more. So degrees should be 1 and 2. So I have problem to build a graph on these 3 nodes with degrees 1 and 2. Yeah, so it is the same problem, just smaller. Okay, so that's again, this, okay, all these ideas I get just by playing with these corner cases. Yeah. Another corner case you think about is, okay, I didn't draw it here. So another corner case when I have only single number. So you have only single number, you have, 4. Then you just build a clique of 5 nodes. Yeah. So, so I know how to get rid of 2 elements, kinda. So I see how it's going. And I know what's happening if I have only 1 element. Yeah. And that's kinda enough to solve the problem. Yeah. Now I just need to figure out all the details. So I have, okay, here I have just rough idea of what's going on. Now I just need to figure out all the details. So I'm drawing the picture which is more detailed. So I'm here, I have dn+1 nodes. Yeah. So some of them should have degree dn. Yeah. So I need to have some nodes of degree dn. Maybe not one, maybe some couple of them. Yeah. So I just draw them here. So these nodes have degree dn. So they're connected to everything. Yeah. Like, okay. Now, in the left, I will have some nodes of degree d1. So I need to have nodes of degree d1. So let's put them in the left. So for this node to have degree d1, I need di nodes in this right part. Yeah. So I have d1 nodes connected to everything. They will be connected to all nodes in the left. So these nodes in the left will have degree d1. Okay, good start. So I have these nodes, I have these nodes. Now, in the middle, all the degrees will be decreased by d1. So I already have d1 nodes connected to all of them, it's not edges. Yeah. So degree of these nodes. So again, I want to reduce my problem to the same problem. Now I need to figure out how many nodes to put in this left and right group. So in the right group, in this group, I have d1 nodes. So in the left group, how many nodes do I have? That's an interesting question. So let's figure out.
Can you repeat this part, please?
So like I'm thinking, just so what's the best way to do it? So imagine you sort all the nodes by the degree. Yeah. So in the right you have nodes of degree dn. In the left you have nodes of degree d1. Yeah. Nodes of degree these right nodes, maximal nodes, they must be connected to everything. Yeah. So I need nodes in the left have degree d1. It means I need that many nodes on the right. Yeah. So if I have d1 nodes here, they be connected to everything. So these nodes are fine. So now I connect d1 edges to all the nodes. Okay, let's draw a better picture for you. So again, imagine you sort all the nodes by degree. So here I have some number of nodes, and degree each of them equal to dn. Yeah. And here I have some nodes, and degree of each of them equals to d1. Now these nodes must be connected to everything. So they connected to each other in all possible ways. Yeah. So all the nodes connected here. And also they connected to everything to the left. So every node is connected to everything on the left. And this node and this node. Yeah. It means that if I take any node from here, it is connected already to every node from this group. Yeah. Now, I need the degree of these nodes be equal to d1. Yeah. So I can achieve it by putting here exactly di nodes. So let's say size of this group will be equal to d1. So if size of this group equal to d1, then each of node in this group has degree exactly d1. Again, I'm just trying to reduce my problem. I don't know what will happen next, so I'm just trying to do something. Yeah. Then I think, what will happen in the middle here? So in the middle here, I will have degrees. So in my reduced problem, I have degrees like d2 minus d1, d3 minus d1, up to dn minus 1 minus d1. Yeah. So in my reduced problem, I must construct a graph with these degrees. Yeah. Now, how the reduced problem look like? Reduced problem look like this. I need to construct graph of dn plus total size. Let me show here. Total size, total number of nodes should be dn plus 1. Yeah. Now, in my reduced problem, the last element is this. So in my reduced problem, I want number of nodes be equal to dn minus 1 minus d1 plus 1. Yeah. So I have reduced problem. I will give it this reduced array and this number of nodes, and it will create me graph that satisfies this thing. Yeah. Okay. Now I just calculate how many nodes I need here. Yeah. You subtract this and this from this. Yeah. So number of nodes here will be dn plus 2 plus 1 in total, minus d1 and minus dn minus 1 minus d1 plus 1. Yeah. Plus 1 is eliminated, d1 is eliminated, and you're left with dn minus 1. Magically. Okay, so the size of this group should be dn minus 1.
Can you repeat this, please? This part.
Again, I just want to figure out what is the size of this group. Yeah. So I know size of the graph, because size of the graph is maximal degree plus 1. Yeah. I know size of this part. I know size of this part. Yeah. So I just calculate how many nodes I need to put in this part. Why size? Because this size is d1, because I want nodes in this left group be completely satisfied. So I want degree of this group in the left be equal to d1. Yeah. So I need to connect them with d1 nodes. Yeah. Yeah. So to satisfy these left nodes, I need size of this group be equal to d1. Yeah. So these right nodes will satisfy these left nodes, and I will live with the same problem, but decreased by 2. So I remove the leftmost element and rightmost element. I have the same problem in the middle. Difficult problem, yes. Again, I'm not sure what is the best way to approach problems like this. So, okay, I just try to explain you how I do it. So I try to play with some small examples and see how I construct these elements. So again, in my previous example here, so here, when I just solve for 4 elements here, so I see that I start by putting the maximal element because I need this maximal. So I need vertex with maximal degree. So I put it and see what happens. So I put it, and now I see, okay, I satisfied not only this node, but also this node. So I have node of degree 4 and node of degree 1. I only need to have node of degree 2 and 3. Yeah. So I reduce my problem to this problem. And then I try to generalize this. Really difficult problem, really difficult problem. Okay, here I'm drawing the same picture again. Yeah. Now the code will be simple, so I just recursively reduce my problem to the same. Yeah. So I will make recursive function build, which solve the problem for the vector D. Instead of having right group and left group, I will make both groups from the right. So I reduce my problem to the prefix. Yeah, just okay. Yeah, so if it's empty, I do nothing. If size is 1, I make just click of all these nodes. And if not, oh, now I do this. I'm just trying to make this thing. So I look at last D0 is D1, yeah, it's zero indexing. Last D0 elements, connect them to everything. Okay, yeah, just connect them to everything, and then reduce my problem. So I take my initial array, calculate numbers di minus d0, here these numbers in the middle. Yes, from 1 to d minus 1. So I remove 2 elements from both person, and just recursively call the same thing. Just output the result, check that it's correct. Oh, here I manually check that my result actually is correct, because I produce different graph than in example, so I check that my graph is also correct. It's very hard to explain how do you solve just math problems like this. Again, like in everything, you need more practice in math problems. So after you solve like few hundreds of them, you just do it better. So you just see all the similarities, you see all the approaches, you see what should work, what shouldn't work. Yeah, just make okay. The trick is to learn which approach will work with better probability. Yeah? So you just look at some approach and think that should probably work, and this should probably not. And to do this, you just train your neural network. Difficulty of H? H is not difficult. H is another construction, but it's actually easy. Again, what is the hint of problem H? Hint of the problem H, the most important hint, is the solution always exists? Again, first hint is solution always exists. And then you look at constraint and see this very strange constraint. And it kind of suggests you that it's something is strange. So this, okay, I believe this just actually solves the problem. So you just look at this and think why. Why C is at least M? And think, that's why. Okay, so you have some, basically what's happening, you have some black region and some white region. And in the middle of them, you need to have some border, yes? And this border should be of these triangles. How do you call them? White, black and white, okay. So you have some black region, some white region. Between them, you need to put these black and white pieces. And if you have at least M pieces, you can always split them with horizontal line. Let me try. I will just draw this picture. Okay. So here I think, okay, I will put black elements here, white elements here, and I will put these black and white pieces in the border. Okay, something like this. Okay, here I'm thinking what is the best way, not like this, like this. Okay, so okay, something like this should work. Looks fine. Now I think, okay, if I have too many these black and white pieces, where should I put them? So if I have exactly M elements, I do it like this, no problem. So if I have too many black and white elements, I need to put them somewhere. And okay, I decided it's actually much easier to put them not in the middle, but put them somewhere in the back. Yeah. So somewhere in the back, I can put all these elements. Okay, here I'm just figuring out what is the best way to do it. Yeah, something like this. That's it. So that's the plan. So I will put, I will make full region of black elements, full region of white elements. Between them, I will put this like layer of black and white elements, like these triangles. Yeah, and then I will put all the rest triangles here somewhere in the back. Okay, bye. See you. Now we just need to implement. Now implementation is tricky. So you need to find the way, what is the best way to implement this. That's also part of the programming. Again, it's programming competition. So you need to find the programming. So I will do it in several steps. So the way I do, so when this implementation have a problem, I usually do it like this. I split implementation in several steps, make them one by one, and just check myself in the middle that I'm doing what I'm supposed to do. So I start by putting here, I just put all the black elements. So I start by putting all the black elements, just moving top to bottom, left to right, like this. Yeah. So I just iterate all the cells top to bottom, left to right, and put all the black elements. And now I will put all the white elements. So I skip M elements for the border, and here I put all the white elements. Yeah. And here I'm just writing the type of the cell. So I have type 0 for black, 1 for white, and 2 for border. Yeah. And here I'll just test my result and check that at this point I'm doing something that makes sense. Yeah. So my pictures produced looks okay. Yeah. Look here, for example, I look at this picture and see, okay, it looks correct. Yeah, so I have black region here, white region here, and here I put all these middle elements, and here I have some rest. Looks fine by now. Yeah. Now I just need to decide how to rotate these triangles. That's tricky. Okay, so here I spend a lot of time. Okay, here I drew a better picture. Okay, I enumerate all the types from left to right, like in this picture. So it's 0, 1, 2, 3, 4, 5. Yeah. Now, in this region, I need to alternate between 5 and 2. So this is 5, this is 2. Yeah. So, see? And here I alternate 5 to like this. Okay. Okay, again, I just drew this picture, and now I will try to implement it exactly as I described here. So I write this loop, I find this middle point x. Now from the x to the right, I do it like this. So, okay, okay, I write it like this. So I alternate between 2 and 5 and 2 like this. Okay, make a break. Okay, that's just flexing actually. You can do it just using if. Okay, yes, and do the same from the left. Again, run the code, check that I fill this part correctly. See? Now I think about the bottom part. Okay, I need to do something like this. Okay, I need to have white color on top. So I need types 3 and 4. And then after I move this layer, I have black color in the bottom. So I need to put next layer having black color on top. So I need to again alternate between 5 and 2. Okay, and now again 3, 4, and then again 5, 2. Okay, then again I thought what is the best way. I decided to rewrite this code actually. Oh, okay, I do it like this. So like this. So I just rewrite my code to make it more clear. Yeah. So I will just fill this matrix from top to bottom. So here I filled the black part. See, first A elements are black. Then I fill this border from A to A plus M. Then I fill the white part. And then in the end, I will fill this bottom part. Yeah. Okay, so it just looked more natural to do it like this. And here I will just copy this code. So I do the same thing in the bottom. Okay, here I have made some mistakes. I will rewrite it a couple of times. Not yet. Finally. Yeah. Okay. It's impossible to read it from here. Let's read it from here. This Python source is accepted. So this the whole problem was this actually. So that was it. So that was your whole mistake. So without these floating point numbers, your codes actually worked. Copy, go here. So here I'm filling the bottom part. Not the best code in the world. So I'm checking what is the parity of the current layer. So D is number of my layer. And J is my horizontal position. And X is this cut point. So if I have even layer, I alternate between 3 and 4. If I have odd layer, I alternate between 5 and 2. Yes, and I have different. When I have to the right from the bottom, I believe it can be simplified. Yeah. So that's it. Now in the end, no, let me finish here. So in the end, after you figure out that these all things look good, so I implement all this part and it looked good. Yeah. Now you just need to output the picture. Yeah. So not this. Here. So you need to draw this picture in pseudographics, yeah, using these characters. So what I'm doing here, I just put these squares into these strings. So for every type, I know which 4 characters I use. Yeah. And here I just output them like this. So I take the type of the element, go to this array, and pick corresponding characters corresponding to this type. Yeah. Okay, here I put first two characters are top ones, and second 2 characters are bottom ones. So I go through the row and print all the top parts, then go once again and print all the bottom parts. Okay. So this last part is actually simple. So after you figure out which type of square you have, you just print the corresponding types.
I have a question about problem G. So basically, we know that there will be D1 nodes, which will have degree equals to Dn, and then with our formula, we can even compute the number of nodes which will have D1 degree. And then we can recursively do it, and then we'll get a count for each degree, how many nodes will be there. So basically, we can convert our degree set to a proper degree sequence out of it. Then can we apply Havel-Hakimi on it?
Yeah, so that also should work. Yes, should work. Yes, you can figure out how many nodes of each degree you have, and then apply standard algorithm for building graphs for the given degree sequence. Yeah, I believe it also should work. Yeah. But it should be much easier than this. So this construction is easy by itself. But if you already have this algorithm nearby, so you can just use it. That's also a way. So you just reduce your problem to another problem which you have algorithm for. Should work. Let's look at your solutions actually. So how did you solve? Okay, not that many people solve problem G, but let's look how you did it. Okay, it should be the same. Yes, so we have left and right. Yes, so every time we remove 2 elements. Okay, so it's not recursively, but I believe it's something similar. Yeah. Okay, it should be something similar. Yes. And this was like mine. So you do construct next array, do it recursively. Okay, very similar. Yes. And the problem H. Let's see what you have. Nice. Okay, so okay, I do the same thing, but just with much easier code. So you can do it like this, so it's okay. So it's maybe easier to write something like this and easier to debug if you made it. Okay, you probably don't make any mistakes, but again, if you copy paste code 5 times, it's always some place for mistake. Okay, I believe it's yes, it's in. We alternate 3 and 4 and 5 and 2. Yeah, basically doing the same, maybe a little bit different. Interesting. So you have special pattern for 6. No, it's not special pattern. No, it's types. Okay, it's probably something similar. I don't think there is much. I don't think there is some easier solution for this problem. Yeah, pictures look the same. So probably something similar. Okay, good for you. So if you solve this problem, very proud of you. Any more questions? Any more questions? Let's see. You're welcome. Is H easier than G or something? I don't think it's easier. So it just requires different abilities. So in problem H, you need to program out. So again, if you look at the size of the program for H, so that's like 64 lines of code. Yeah. If you compare it to problem G, from G, very short solution. So that's the whole solution of problem G. Yeah, so problem G just requires a lot of thinking and mathematical intuition. Problem H requires more implementing. So still you need some mathematical intuition to think which place, but then also it requires some implementation. So maybe less math, more programming, but again, it's hard to measure difficulty. Well, let's Google search. How do the difficulty rating of it? I don't remember. The difficulty is about 2000 something. Again, difficulty on code forces is not very precise. Again, it's hard to measure difficulty. So it's just some number. So when I pick problems, I look at the code forces suggested difficulty, but it's not always correct. So sometimes I swap problems because they have. I think this problem is easier. I didn't think that G is easier than H. So H looked like a hard problem. So it requires some thinking and programming. So it's H is not easy problem. And F is not easy problem. Okay, if you don't have any more questions, so let's stop here. Okay. So thank you for watching. See you next week.